I'll stop here right now. If y'all still have more questions on Wednesday, I'll go a little further. Okay? So that's the approach I would take.
If we knew that top span up there, we wouldn't have to worry about doing all those steps, correct? I mean, but as long as you have the length of one of the sides, then you can start floating stuff.
Yeah, but you don't.
We measured it.
It's not the distance, it's the force, though. These vectors represent, it's not distance. These vectors on this one are force.
Okay.
So that top, all that would give you the angles. You've already got the angle. You've already got the geometry of the problem. So that physical length doesn't have anything to do with these forces. Doesn't matter how long that piece of rope is. You know, I don't have any dimensions over here at all except for the angles. I don't have any lengths or heights. Not important. You could have that problem. You know, it could be on this scale, a little tiny, 35 pounds, or it could be really huge at the same geometry, 35 pounds, you'd have the same force. So that length isn't proportional to the force. All that does is describe the geometry. What we need to know is if we know AX or BX, but that's not a physical length, that is a vector, it's a force.
Okay.
So start going through, just literally, just try different combinations of the SOHCAHTOA, these different angles, and try to start substituting equations, and you can get them to cancel out. You can solve this problem.
When you're talking about canceling out, or because you kind of scrolled those two down there, and you said you were like rewriting them and stuff, you know?
Yeah, I just saw that these two both had an A in them, so I solved this one for A right here. I just multiplied both sides by A and then divide both sides by sine of 60.
Right.
So I just say A is equal to AX divided by sine 60. I did the same thing for this equation right here. Then I saw that since these both have an A, I can set them equal. So this one is equal to that. I wrote that here. I'm just playing around trying to find some relationships that I can stick in there without having a real direction. Because sometimes you don't have a direction. If it's a problem you never solved before, you know, you got these two equations. If we can just simplify it a little bit, we're there. All we got to do is solve for any one of these, and we're good. Let me give you one more hint here. I've got this AX written in terms of AY. See, I can take this one step further. I can say AX is equal to AY divided by sine 30 times sine of 60. So I've taken this here and I rewrote it in terms of AX. Right? Okay. So I can take this AX and I can stick this up in here. And this is going to look funny. AY over sine 30 times sine of 60 is equal to BX. Right now I've only worked on the right side of this triangle. I can do with that BX, I can do the exact same thing on this other side. So I can write the BX. I need to take this BX and write it in terms of BY. Okay? If I get this, where this equation has AY and BY, and this equation has AY and BY, two equations with two unknowns. Y'all remember how to solve that? Y'all have all solved that at some point in an algebra class. That's two equations, two unknowns. I just made up two equations. Y plus 2x equals 4, 2y plus 3x equals 8. What are y and x? So it's two equations, two unknowns. So the first thing I'm going to do is take this y and write it in terms of y. Y is equal to 4 minus 2x.